Okay, Sebastiaan de Vet, go ahead.
Thank you. Hello, good morning. Have you ever had that feeling when you're standing somewhere in a landscape and this sort of feeling creeps up on you that you're standing somewhere on the surface of a different planet, like the planet Mars or maybe the moon for that matter? Well, chances are that that feeling that you're having is much more real and much more important than you can imagine, because a lot of the things that we know in science and in planetary science is driven by the resemblance of landscapes that we have here on Earth. Of course, Earth is a very blue planet, like the beautiful screen that we have up here at the moment. Later on, I'll just have a very nice picture of it. But the nice thing is that if we switch to the next slide, that the way in which we are looking, can we perhaps get the next slide? Thank you. The way in which we're looking at the surface of other planets is really driven by the way in which we're perceiving the world around us. And this is a very powerful way of looking at those planets. This gentleman over here, Christian Huygens, was one of the very first astronomers that used his own telescope to look at the planet Mars. And I'm taking you back to a night in November 1659, when he used his own telescope to look at Mars. And when he did that, he saw a very interesting sort of black little patch at the surface of Mars. Quite peculiar, and he didn't really know what this was about. Being a Dutchman, of course, he was looking around him and trying to find an explanation, and he thought this might be a peat bog on Mars. Well, quite an interesting idea, a little bit muddy, a little bit dark, so it could fit the profile of the thing that he was seeing. But of course, in all the subsequent years that they were observing Mars, the image that we got from the red planet gradually changed. In this case, for example, H.G. Wells, a very good example of how even popular culture was responding to the state of art in science, in planetary science, at that point in time. But in reality, our view of Mars really changed thanks to the beautiful development of spaceflight. I'm going to put down the globe for a second, because if we see the next slide, this is what we can see nowadays. This is a picture made in the 1970s by the Viking landers, and here we can see a very beautiful landscape, which is a lot more diverse than what we can see. We can see sand seas, river systems, polar ice caps, and we can even see the largest volcanoes in our solar system. Now, by far, Mars is a lot more diverse and a lot more dynamic than what we could see in those very early sketches that were made by Christian Huygens and his contemporaries. But that little black patch that Huygens saw is actually there on Mars. He was actually able to see a little black patch that we even find there. Cetus Major and the surrounding area, that little triangle, that's what he saw. So even though he had the idea this might be an interesting spot on Mars, we see it's nowadays very dry, very sandy, and not really the sort of peat bog, the dry area that we saw nowadays. But thanks to the modern day advancement of spaceflight, and this is really what gets me excited on the planet Mars, because we are now getting pictures with the resolution, with the sharpness, that we can distinguish between details the size of the seat that you're currently sitting on. That small. And these are some of the pictures that we're seeing about layers in rocks that, to us as geologists, can tell us something about how these landscapes developed. Parts where we have very cold terrains that are altered by freezing and thawing of the landscape. And at the same time, we're also seeing something that's quite remarkable. And these sand dunes, these materials, this is what really gets me excited on the planet Mars. These are sand dunes, and they are moving. Now you might think, okay, sand dunes, they're supposed to move. But if you imagine that these sand dunes, they're not only composed of volcanic glass, or not even anything resembling on Earth might be composition-wise related to this, but they are crawling across the surface at a pace of about 1 meter per year. Now this doesn't seem a lot, but if you imagine that the atmosphere of Mars, that Mars as a planet, is quite different. This is Earth, and size-wise a comparison with the planet Mars, you can see that these two planets are really very different. Mars, compared to the Earth, if we get the next click, we can see that gravity is only 40% of what we have here on Earth. The atmospheric pressure is just 1%. So all those things that are, all those mechanisms, those processes that are driving the development of the surface of Mars, they're actually influenced by these, what we call planetary variables. They are causing those landscapes that we see here on Earth to differ in their way in which they develop and evolve on the planet Mars. Now, of course, we need to translate these processes in some way to understand why those dunes are moving. And this is some of the science that I'm doing here at the Amsterdam Science Park. And we have a wind tunnel in Denmark with some colleagues, and we are looking at very small deposits of sand, and we are trying to understand how those sand particles are blown away by the wind. And in this particular wind tunnel, we can take out the atmosphere of the Earth and put in the atmosphere of planet Mars in order to understand how these sand particles are blown around. And what we can see is that the very gradual rolling can give these sand dunes the initial kick to really get them moving along at this incredible fast pace of 1 meter per year at the surface of Mars. Of course, fast in this case is for us very fast, and maybe a little bit smaller. But there are many other processes, even in these sand dunes, when these particles are moving around and they're flowing down in avalanches on the lee side of the dune, we're trying to understand how this happens. We can fly parabolic flights where we reduce the force of gravity, in this case during sunset above the Noordzee. It doesn't really get any more romantic in science if you can do this kind of stuff, of course. But we are really up close and personal with the sediment and trying to see how these avalanches are flowing across the surface of Mars and trying to understand how this landscape differs on Mars compared to what we are seeing here on Earth. For me, Iceland is the place to go to. If you're talking about landscapes where I can find my own little piece of Mars and where I get excited, Iceland is definitely the place. And these are some of the pictures where we have these very beautiful landscapes formed by volcanic eruptions. In the lower part we can see these very nice table mountains where volcanoes melted their way upwards during the last ice ages and created these sort of custard-shaped volcanoes. We can see craters formed by the explosion of lava in contact with the water in these lakes. Grand canyons really formed out by the catastrophic floods that were flowing away from these glaciers during eruptions. And the nice thing is that for all these different very nice volcanic landscapes, we find exact replicas on planet Mars. And the very cool thing is, these pictures are some of the pictures taken by Mars rovers and orbiting satellites that really show that these landscapes in Iceland are very comparable. Of course, because Mars is a little bit smaller and has some differences as a planet compared to Earth, we need those experiments and the landscape together to really combine and understand what is happening at the surface of this planet. And in particular, for me, if we go to Iceland, it's very simple. I don't need to travel 250 million miles on board a spacecraft all the way to Mars to study the surface of this planet. I can book a ticket, I can book a Land Rover, and just go to one of those spots here on Earth, right then, right there, to do my science and really understand what is happening on this globe, to understand a different planet in our solar system. Thank you so much.
Thank you, Sebastiaan. Now, my first question is, why did you bring planet Earth in this color?
Well, this isn't. Well, it's nice that you call it planet Earth because it's actually planet Mars.
I don't know what it is.
So it's already clear that this comparison between Earth and Mars is very appealing. But one of the nice things is that if you look at, for example, those very first sketches of Christian Huygens, of course he was seeing this with his own eyes, without the aid of a digital camera or a fancy telescope, just with a very simple thing. And nowadays we can actually use the images beamed back by satellites to produce a globe that you can just hold in your hand and you can play with it and look at all these surface features. You can actually see the black triangle that Christian Huygens already saw in his telescope in 1659. So this is really cool stuff, really powerful stuff to work with, and trying to imagine how all this diversity at the surface really paid off and developed.
And why is your research important for Earth?
Very good question. I mean, one of the nice things is that because the science that we're doing by combining landscapes on Earth with those on Mars, we can also use the things that we learn directly here on Earth. For example, those wind tunnel experiments I was showing, for decades we've been looking at wind tunnel experiments, trying to understand the effect of the atmospheric pressure on Mars and on Earth. But no one has really thought of looking at maybe the difference in pressure that we have in the mountains here on Earth. So if you go up to a mountain of 3,000 somewhere in the Alps and you feel that you really have to catch your breath, well, that effect is something that affects us as a human. But at the same time, those sand particles, the sediments, they are also influenced by those pressures. So thanks to those experiments, we are really trying to think of ways of how we can take what we learned on Mars and apply it, for example, in ecosystems, in landscapes where we can see influence of climate change very high up in the mountains to see whether erosion is maybe going a lot faster or maybe a lot slower than what we would see at sea level. So it's a very, again, very
Useful.
nice, very useful way of doing this type of science.
Okay, thank you very much. And if you still, if you want to know more about Sebastiaan, and if you want to ask him some questions, we can do that after 15 minutes. Thank you, Sebastiaan, in the Media Cafe on the left.